Next question. A hole of diameter of D is to be punched in a plate of thickness T. For the plate material, the maximum crushing stress is 4 times the maximum allowable shear stress. Okay. For punching the biggest hole, the ratio of diameter of the hole to the plate thickness should be equal to. So here we need to find out ratio of diameter of the hole to the plate thickness. That means we need to find out the D by T. So here, no, there is a plate here. So in this plate, I want to make a hole. I want to make a hole by using the punch here. So here, when I push the punch down the plate, then the hole will be formed like this here. So if you see on the top view, I will draw here. If you see in the top view, then this will be plate. So the hole will be like this, and the diameter of the hole is T here. Okay. So here, what are the other conditions that they have mentioned? First of all, what is happening here? So when I try to push this, through the plate, then what is happening? There is a resistance to this. Okay, when you are trying to push this, then there is a resistance to the die or the punch, whichever you are trying to pierce through the plate. Okay, that means it is trying to crush it. It is trying to crush it, and the plate is exerting the same amount of resistance in the upward direction. Okay, so that means there is a crushing stress that is opposing the movement of the punch. And if the crushing stress is very much high, then what happens? There won't be any hole produced in the plate. Okay, so the mechanism is like that. You need to increase this crushing force. I need to increase the force slowly. Then what happens after some time? The edges here start shearing. They will start shearing. Okay. So when they start shearing, then what happens? It will tear off. Okay. So that means here, what is happening here? So here, for example, this is the portion. Initially, this is the portion. It is tearing off. It is tearing off, and the same process will continue until it reaches the depth D. Okay. That means here, if you take the area, this area, lateral surface area, for example, this is the area. For example, this is the area, and it is coming up to here. Okay. So it is something like if you take the cylinder, so this is the outer surface area of the cylinder. Okay, that much amount is subjected to the tearing. Tearing means here nothing but the shearing. Why shearing? The force applied parallel to the surface here. The punch force is applied parallel to the surface here. So here, how many stresses involved in this? The stress produced due to the applied force, that is nothing but the crushing stress, that is called as a crushing stress. Okay, and the shearing stress that is tearing of the material and finally producing this hole. Okay, so let's say this shearing stress is nothing but a tau, and the amount of crushing stress that is applied on this what we call this punch is a sigma. Okay, so it is given that sigma is 4 times tau. Okay, this is given in this. Okay, so always if you want to deal this type of problem, then how to do this? While explaining about the equilibrium equations, I always mention like you can always equate the forces, not the stresses. Whenever you want to equate, not only here, in entire engineering, whichever branch you take, whenever you want to form some equilibrium conditions, then you can equate only the forces. You cannot play only with the forces. Okay, so here what are the forces that we have? There are 2 types of forces corresponding to the 2 stresses. Okay, so what is that? One force is corresponding to the piercing stress or the crushing stress. Okay, so let's say FC is related to the crushing stress, okay, and it is related to the sigma, and the another one is the FS, that is a shear force. Okay, so here I need to equate this. When FC is equal to the Fs, then only the whole is becoming possible here. Okay, so what is the FC? FC is nothing but here how much force I applied at the top. So otherwise if I write in terms of the sigma, then a sigma into area. What is the area here? Area is area of the this die or the punch. Why? Because this crushing stress or the force is because of the punch here. Okay, so this area is related to the punch, that means pi by 4 d square. Okay, that equal to shearing force. Shearing force is nothing but a shearing stress tau into area here. Let's say this is A1 and this is A2. So how to write A2 here? What is the A2 here? A2 is nothing but the outer surface area of a cylinder. Okay, so this forms the cylinder. If you see this is like a cylinder starting from here to there. So how to calculate this? This is a tau into A2. A2 is the circumference. You need to calculate the first the circumference and then you multiply up to the depth t. Okay, then you will cover the entire surface area. What is the circumference? That is a 2 pi r pi into d multiplied by the thickness. So thickness is from here to here. What I am doing, first I am calculating the circumference and I am multiplying with the t. So what happening then, I am when I multiply it, what happened, I keep so many rings like this, total rings, and then up to depth t I am keeping all the rings and I am calculating the surface area of the outside of all these rings. Okay, that is what we are doing here. So here t. So but there is a relation between the sigma and 4t. So if I substitute that value, then 4 tau into pi by 4 d square equal to tau into pi dt. So pi d will get cancelled, tau will get cancelled, and 1d will get cancelled. So what is the final thing that we need? D by t, right? D by t, and 4 will get cancelled. So d by t is 1. Either it is a d by t or t by d, it is only 1. Okay, so what is the answer? Answer is C. See here, since it is the first time I am explaining, it took this much of time, but you need to remember. You need to remember always. For example, if you don't get this much idea, like here we need to equate the the force that is causing the crushing to the force that is causing the shearing. Okay, always you need to always need to identify how many stresses that are produced here. Okay, so each stress is because of some force. Okay, so you identify those forces and try to equate those. So by doing that, you can get the required answers here. Okay.